I found this humorous. So this is the second shirt I have with the humorous on it, and I thought I'd bring that up to talk about APIs and subtle nuances and their differences. I'm Mike Levin, and this is Tuesday, March 2nd, 2021, and I'm finally getting to a video that I have been wanting to do. It's going to be about persistent dictionaries. But I thought I'd open up by, showing you the stuff I do in the morning, the Control-Alt-T for terminal in order to type or to think, because Vim is nice for that. And then I CD'd in my GitHub directory because terminal drops me into my home directory, and I always have a GitHub directory in my home directory. And then I CD into journal, and then I type Vim journal. And now that brings us to here. I'm typing to you in Vim because why not? You got to use some sort of tool to bounce your ideas around. Some people throw spaghetti at walls, others never trust their own thoughts and compulsively seek advice, thus never really experiment and just learn for themselves. And we wish to experiment and learn. And despite the lovely, alluring staying power of Vim all the time, we must explore and go outside of Vim. Yes, and so this video and then a bunch of stuff that I copied and pasted over from Simple Note that I think I'll make some other video about. There's those thoughts about the levels of abstractions and nuances of API, blah, 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 blah. And that brings us down to tricks. In my settling into my new hardware, this new laptop that I'm on, it makes you take inventory of tricks. And one of the tricks I've not been entirely satisfied with how I have handled in the past is making dictionary objects, key value pair objects like JSON, persistent so that they work like databases. And perhaps you need a database, but what you don't need is a headache. And I have been at this for a long time with everything from, all the Microsoft ways to do this back in the day with personal SQL Server and using Microsoft Access as a database. And there's just many more ways to look at a database than I imagined at first. And a simple Python dictionary data object is a small dictionary. It looks just like a JSON object. It's got key value pairs. Problem is it poofs out of memory right after you, the program stops running. And so with Python, you could pickle it. It's easy to get objects in memory, drop them onto the hard drive. And in fact, this little example of how to do it brings us to the main thing I wanted to talk about, which is besides the persistent dictionary itself, but it's the context manager. It's an API convention with, and usually the word open, but not always, and then the word as. So the real pattern is with some sort of open event or, instruction, and as, and then a file name. And this example with eggs and spam comes right off of the official Python docs.python.org, comes right off of their page. I copied and pasted it there. And they're showing you, this is the way to make an object persistent in memory between program calls. And it's not persistent in memory. It's stored to the hard drive and then pulled up off of the hard drive. And they give the mandatory warning that because the shelve API that uses pickle underneath is because it's based on pickle, it can execute arbitrary code. The thing is, you've pickled it yourself. It's your own system and you control everything that goes in and out. That can't happen to you easily. However, it is something everyone ought to know when dealing with things that use pickles on their internal, which, I'll jump ahead and let you know that this guy does too. SQL Dict internally uses pickling. I'm not sure whether disk cache does, but I'm going to talk a moment about that. And the context manager. It has an implied try finally that closes the connection at the end. One of the problems with things that open off of the drive or database or whatever is they have a explicit close that needs to be carried out at the end. And now, because Python has this try finally operator that ensures that this always occurs after it got past that point sequentially, that guarantees a close. However, all this scaffolding, all this conventional arrangement of logic can be wrapped into a sort of implied syntactic sugar when you have your with and your as keywords there. So when you see with and as, this is what it's really doing, context manager. And you see that all sorts of places. I believe we saw that in the code that I really, really liked from the past few videos with as, right? We're using the context manager in an asynchronous context, I might add, when we use the HTTPX package to gather its crawling data from multiple concurrent HTTP calls. So that's the context manager. And we're going to use that on the Sqlite dict package, which is not installed on my machine yet. So it's time to go to a new example. I could do it at the bottom of this video that I've been using, this notebook that I've been using on the past few videos. But it's time to rename these things and let you see a little bit of good hygiene, even in my GitHub/test directory, such as we're in. We're testing multiple methods of concurrent HTTP. This is concurrent requests. So this is where I test concurrent requests by 3 different methods. If you haven't watched that video, import requests, here's doing it in sequential mode using Python classic, although list comprehension isn't as classic as it gets in Python. It's sequential list comprehension, which is map reducible, which is why you see the list comprehension API reoccur everywhere. However, it's not actually doing things concurrently with this method. We have the concurrent method, which uses the built-in async IO library, now standard in the standard library for Python. And we're using the HTTPX external package to do the same thing, but you can see with a slightly more complicated syntax in order to do it concurrently. Thankfully, there's a context manager here with as, so I don't believe it locks you into async mode. You can continue with sequential style underneath such an indent with context. I believe so. I'm going to test that, but I think this is really cool. And then finally, I show the multi-processing. You're going, oh, well, that's just concurrency. That doesn't use your multiple cores. Well, if you have a machine with 8 cores, you set this number to 8, and then you run it with this version that actually does split it up over multiple processors. Although I found some weirdness that one of my YouTube users explained to me about back-end pickle communication between processes. I still have a little to learn. But we want to hit new here, new Python notebook. And whereas it was concurrent requests there, we'll rename this one right off to persistent dictionaries, persistent dictionaries for non-Python people who might tune in. We understand the official short name of a dictionary, even that we call it a dictionary. These things are go by all kinds of names. They go by JSON, and it implies a certain level of flexibility. There's not rigid data structures being enforced here. So key value pairs. Anyhow, we don't have this library yet. I've seen people pip install right off of the notebook. It's nuts. But I'm going to try doing that. I saw that done on YouTube. Usually you'd have to put an exclamation before it, but we're doing this. And I would usually do Python, -m pip to make sure that it uses the correct virtual environment and everything. But I saw a demo out there where someone just did this, and I think Jupyter Notebook recognizes that now. It's an amazing thing. And this has to be Jupyter Notebook enabled. This would not normally work doing a command line terminal command off of a Jupyter Notebook code cell, but there you have it. It did work. The notebook environment is evolving to support the way people want to work, even if it's creating strange little fuzzy curly Q exceptions. So if I ran that again, it would probably say requirement satisfied because it's now on my machine. And once it's on your machine like that, you can import SQLite. But before I just do that, sometimes Sqlite dicts. Different things. There is a SQLite, so let's not get confused. I don't want to make that mistake. Before I just go ahead and do that, which will load the whole object into memory, let's look at the instructions on their site. So I'm going to first point out how there is this mydict.autocommit. And so, see, pickle used internally, just as an FYI. In this example, from SQLite dict, import SQLite. So I'm glad I read it already. They're importing a sub-item from the master package. So we'll probably do the same. And they have auto commit equal to true, you'll notice. So that means I see no commit here. But I also see no with as, and therefore I see a close here, right? So there's a pattern here. This is the old-fashioned way of doing it, where you explicitly open an object off of the drive in this case, in so many cases. You do something that interacts with it, and then you close it at the end. So that's one of the types of sample codes, in which case you don't have to commit as you go along. Auto commit equals true. Now on this example, we see the with, and we see the as, and we see a, quote, file handle, a handle, a pointer. It's the same as a variable name. I have to make a video on that, how handles, file handles, variable names, references, all kind of the same thing, even though they have different ways they kind of get popped out and exposed from the object. In the case of the context manager, it gets popped out after an as. You see that in SQL. That SQL uses that convention to rename things once they're asked for. So anyway, that's clearly the pattern we're going to be using. And in fact, I think we can just build what we want right here. From SQL, don't even need to read it. Just instead of the import I was about to do, we just get this object. From this bigger package, have that object. Now we're sitting on that object, and we don't even need this anymore. The official docs. You understand context managers now. And now we're up to, oh, disk cache. Why SQLite dict instead of disk cache, a big contender. In fact, disk cache has some other capabilities I would like to see, like decorator caching. You can use this to add a cache to any system transparently, as if you weren't even using a database, a key value pair, this other way I'm teaching you to use it. And that's nice. I kind of sometimes use that. And this is made to scale. This is made to back-end sites that need high-performance caching, oftentimes on the Django platform. In fact, it is too much for my purposes, and this other one pitches it as a lightweight way to do it, and it only just uses SQLite or SQLite on the back end. It doesn't use these other techniques. So you can watch the files get created. In fact, I'll remind myself to do that by bringing up my Windows Explorer. and we'll do a before and after, right? So I'll go into my GitHub folder, which is always in home. So we go there, go to my GitHub folder. I guess for the future, I really do want GitHub on my quick shortcuts. So we'll add it there, and then we'll drop into my test directory. And you can see the stuff that has been created so far. And this will be sort of a before and after. Notice it's just 3 objects in there, 3 items. There's going to be a 4th in a moment when this SQL dictionary is created. SQL dictionary, Sqlite database, really. I'm not using that example. I want to use the context manager and deliberately commit my changes as I go. So this syntax here we start with, copy, go over here. It's usually better to type it out so you really know what you're doing, but it's not that much to follow. With that object we just imported, we're going to create something, mydb.sqlite. I don't like that convention. This is temp because we plan to throw it out, .db because everything with a .db extension is SQLite. MyDict, cute, but this is a file handle, and I want to make sure you understand that it's, a database connection object. In fact, we're going to look at what we're expected to type next in the example to know how to name it. We are going to be using whatever word goes there and using that as the key name. See, not the key name, this is the key name, but as the dictionary object name. So it's a SQL dict, okay? MyDict. So that lets you know it's persistent. SQL dict key name, foo equals bar. And before I even execute this, right, I am going to put the before and after above this. Above, and we're going to do x equals x equals blah. We're going to execute that. And now, I haven't really run very much here. We don't really need this pip install anymore. Okay, but blah is in memory, and if I added a new cell and I typed x, we would get blah out. However, if I restarted the kernel and cleared all outputs, x no longer contains the value. X is not defined. Just because it says it there doesn't mean it's been executed. See, this is the first thing to execute since I restarted the kernel. If I were to go like this and then this, now x has its value again, except for the fact that it got loaded in, through a programming command. It didn't automatically read it off of the drive. Okay, so if you want x to load its value out of the SQL dictionary that we're about to use, we get rid of this thing that defines x. We can show x down here, and we can say SQL dict x equals bar, and we execute that. The key value is x. That might not be a good idea. We should put arbitrary key, a key, arbitrary key equals bar, right? Okay. So we're going to look for value of bar there is no actual value set. Let's just do this example. Import the library, set that key, and it's already closed. So no matter what I look for here, it's not going to be there. See, if I do this, that dictionary is closed already. But if we set something equal to it inside the context manager that survives its little journey outside the context manager, it will have it. Because as a feature of Python, it's not necessarily this way in other languages. Even if you create a variable inside an indent, inside a code block, an implied loop really, that new internal variable is available external, globally. So anyway, this won't be here, but x is now here, and we get the value bar out of there. And to just hit this point home, I restart my kernel and clear output. Notice nowhere is this really being set to bar. In fact, now it is being set to bar. So to make what I'm about to say true, we are going to now change this code. We're going to remove this entirely. We're going to just say x is equal to whatever value is in the SQL dictionary with the value a key, with the arbitrary key a key. So you'll see bar is not, well, okay, x equals here. Yeah. Okay. It should be there. I hope I didn't ruin this video with a bad example, but this is what this kind of stuff is all about. SQL dict a key should be there because that database has now been created. There's a little bit in there, and amongst, oh, I didn't commit, right? I said commit is necessary. Boom. So it's not really committed to the dictionary without that command. So we need this. And the good news is the commit doesn't have to be on a per key basis. You can just commit the whole object, which is the reason I'm actually choosing this, because it turns out if you actually do implement the loop, which is coming up, you'll see some more advanced use of this. We're going to commit every 50 instead of every loop through. Or every field, because it's much more efficient, but I won't get into that in this video. But now that I actually plugged that value in, and you'll remember that this was, okay, it's still 12K, it didn't get any bigger. I guess that's the overhead of it being there. We should be able to symmetrically reverse that, turn it into a read-only event. Now back to where I believed we were before. We will restart the kernel and clear all outputs. So again, you will now notice the word bar is not anywhere in the picture. See, you can't see bar. But when we open that database object, even with a context manager, you can open it for reading, we can open it for writing. Those are other things we'll bring up later. I'm using the default, which must be writing. Well, we'll find out in a moment if it's writing. But the value of a key is stored in tempdb there. So I should just be able to hit X and we see bar. End of story. That's a dictionary object, and it's a persistent dictionary object, and it's one with this nearly one-liner kind of coding style that I'm really digging. It's hard to do true one-liners in Python because of the indents for code blocks. Lambda seems to be where so much of that one-liner art form lives in Python, as opposed to like regex in the Ruby world. But with context managers, these are honorary one-liners because that, with as on its own line, it's hard to get away from. And then it exposes an internal, file name, and file handle, and then you use it, and you can use it with a commit. So I don't feel like I got across quite how cool this is. So say you import the requests library and you perform a search against Google. A search equals https://google.com. I guess I'll put the www. I don't want any auto forwarding. And if I remember it correctly, it's /s?q equals test. And of course, I'll test that. Okay, it doesn't like that. Search. Okay, you use the whole word search, and then I'm pretty sure it's going to be, the q equals. So we'll just delete all that and say q equals test. Okay. So that's our search, and we do requests.get a search. And just for our edification that this really works, text, you'll see the output. Oh, requests, that singular plural thing always gets me. You'll see the output of a Google search here. So, that's basic web scraping. And we're going to put that into, view source. Okay, so now we've got the view source of that scrape sitting here in this object. And you want that again later, but you don't want to use a database, right? You're starting to get the idea. You can use whatever you want there as the key, but let's use test as the key. Equals view source, and then we won't forget to commit this time, but the commit only has to be on the SQL dict object itself. And again, we don't have to close because the context manager. And we'll do a before and after because of the tiny bits of data we've been using. That's only 12K right there. I execute this, which is going to have some, size in it, and that 12K jumps up to 56K. It's a real dictionary, folks. And you could even delete it. Python won't complain. The operating system won't complain. Because this is a REPL environment and things that it thinks are there have disappeared, you might get some errors there. But that's what restart kernel is for. It just cleared your dictionary out if you want, or you cleared your whole database out. It's just not there. See, 3 objects, and then boom. We won't even do that one. We don't need it. That was for learning purposes. We don't need that. Import requests, that'll be necessary for what we're about to do. The search, performing the search, and then writing it into your dictionary. It reappears, same file size, but now we'll restart everything that's gone from memory, right? It's no longer there. However, it is. We just need that. And then we do the symmetrical reverse, right? This is a point you need to get. Whereas I was setting a key equal to a value, I am now setting a value equal to the retrieval on a key. Okay? And I don't need the commit because it's a read-only event. And there is my web scrape. Persistent dictionaries, ladies and gentlemen. You could do that against 100 searches or 1,000 searches. I'm not suggesting you do, but if it only grows by about 50K per query, it's a pretty cheap and easy local database with very little overhead and a little bit less technical liability than what? The alternatives that pop into people's head for things like this. Redis, Memcache. I probably am spelling this wrong. I think it might be 2 Ds. I'm not even sure. Who cares? Other things. Oh, well, the grown-up version that's like what I'm using. Disk cache. I'm not saying don't use it. These things are what you would use if you were doing website development and you needed a local cache that did a lot of this type of stuff, especially if it was scaled out over multiple sites with, load balancing and stuff. Having more complex architectures that support parallelism and stuff is a good idea. You don't want to back end everything you do with Sqlite, but it does even replace, what we're doing is less technical liability than even Sqlite 3, which is what it is. You can just import the library sort of raw with SQL syntax, because SQL is a way of communicating with a database, but having to do everything through SQL syntax is something of a liability. A subpoint there is what we're doing is we're recycling our key value pair knowledge from standard Python dictionaries. Again, it's that whole concept of standard API recycling, where the CPython standard library, the reference specification, gives the examples and things like its native data types, and then other things follow suit and copy the standard APIs so that they copy something we already know. We already know how to use Sqlite dict external package because, you know, of standard APIs. And the final thing is it's not just the dictionary standard API it's also using the context manager optionally. So maybe I will demonstrate the modulus operator to do it now, because then I have to get into loops and it would extend this video by like 10 minutes just to do that. A single key value pair in a dictionary structure that could handle thousands. I mean, you understand that if I were to do a different query, this is on test, let's do it on, you know, a search on the word foo. That's a different search. That contains different text. Request is not defined. Helps if you import your library. Out of order operations are always something you got to keep in mind. Try not to do it in notebooks. Try to always go in order. Or reset and clear your output and go top down. But that should be foo. And to get it back out, view source equals plugging the keyword foo in. And now view source has a different value. It's a search against the word foo rather than against the word test. You're going to see a lot of footers, but then as you search, you know, there you go. There's some web scraping. And you can do that with plenty of data types that you can imagine. This is not just a scraping tutorial, but anything you fetch from an API. Very typically, what's view source of a search here would be a JSON type object from hitting against an API endpoint. I call this a search, but that might as well be, you know, API endpoint. Oftentimes when you make the request, it's not just request get. You have to do something like, you know, headers equals, and then you have some dictionary that you created that has your authentication token and stuff like that in there. So mission accomplished. Thanks for joining me. Hope to see you again soon. And don't forget to make your dicts persistent. Locally at little to no cost. I mean, this is just such a great way of operating that, you know, there's no reason you shouldn't be doing it. Replace your shelves, your pickled shelves, if you use them, and don't become a DB admin if you don't have to. That's the takeaway. Thanks for joining me. Hope to see you again soon. Don't forget to subscribe.